We're all swimming in this invisible ocean of information, right? All the time. It's radio signals. They're carrying everything from TV shows and satellite data to these super weird, mysterious signals that bounce all around the globe. And today, we're going to pull back that curtain.
I mean, really think about it. What if you could actually see that ocean of signals? Not just know it's there, but tune in to any part of it and figure out what it's all saying. It sounds like something straight out of a spy movie, right? But it's actually way simpler than you think, and it all starts with this.
This little thing right here, this is the key. It's not some crazy, expensive piece of government gear. It's a cheap little USB stick that was originally made for watching TV on your computer. But then, some people figured out it could be turned into something way, way more powerful. This is an RTL-SDR.
So how on earth did a tiny TV tuner become one of the coolest tools for radio explorers? Well, it's a pretty awesome story of some clever hacking and a big discovery.
Okay, so back around 2012, some seriously smart people realized that the chip inside these cheap TV tuners, this RTL-2832U, was way more powerful than it needed to be. They figured out that if they wrote their own special software driver, they could just totally bypass the TV part and unlock its secret ability to become a wideband radio receiver. And just like that, the RTL-SDR was born, and it blew the doors wide open for everybody to get into the world of radio.
So, that's the origin story. But what does that term, software-defined radio, actually mean? Well, the name itself is a pretty big clue.
With a software-defined radio, or SDR, all the heavy lifting, filtering out static or decoding a signal, isn't done by physical knobs and circuits anymore. Nope, it's all handled by software that's running right on your computer. And that is a complete game changer from how radios used to work.
Just think about it for a second. A traditional radio, it's built for one single job. All its parts are hardwired to pick up, say, an FM station. And that's pretty much it. But an SDR, it's like a chameleon. The hardware just grabs a huge chunk of raw radio data, and then the software decides what it becomes. With just a click of a mouse, you can turn it from a regular FM radio into an air traffic scanner and then into a satellite decoder. And this, right here, is its real superpower. Instead of just blindly turning a dial and hoping you stumble onto something interesting, you get this amazing visual map of a whole slice of the radio spectrum. It's often called a waterfall display, and it lets you literally see where all the signals are. It makes finding things not just possible, but super easy and kind of fun.
Okay, so you've got the tool. But the radio spectrum is a gigantic place. It's like a new city you've never been to. To really explore it, you're gonna need a map. You've got to know the basic rules of the road.
The best way to think about the radio spectrum is like a city with a bunch of different neighborhoods. Down in the low-frequency part, that's HF, or high frequency. That's where you find all the long-distance travelers, global AM broadcasts, amateur radio hams talking across oceans, even those creepy, mysterious number stations. Then you move up to VHF, that's the local part of town. You've got your broadcast FM radio, air traffic control, and weather satellites flying by. And then way up in UHF, that's the super busy downtown commercial district with all the cell phones, Wi-Fi, and all kinds of wireless gadgets.
And the whole reason these neighborhoods exist is because of how the signals actually travel. VHF and UHF signals, they pretty much go in a straight line. It's called line of sight. So if you can't see it because of the curve of the Earth, you can't hear it. But HF signals, or shortwave, they do something incredible. They shoot up and bounce off a layer in our atmosphere called the ionosphere, kind of like skipping a stone in a pond. And that's what lets them travel all the way around the world. Pretty cool, huh?
Now, if you want to listen in on these different neighborhoods, you need the right antenna. And there's a really simple rule to remember. The higher the frequency of the signal, the shorter its physical wavelength is. So your antenna has to be the right size to match that signal. This is one of those times where bigger is definitely not always better. The right size is what counts.
Okay, so we've got the basics down. Now we get to the really fun part. This is where the magic happens. With the right software and the right antenna, what kind of amazing stuff can you actually find out there?
Get this, you can track airplanes in real time. Seriously, planes are constantly broadcasting their location, their altitude, their speed, all in one frequency, 1090 megahertz. Your little RTL-SDR can pick up those signals, and special software can plot them on a live map of the sky right above your head. It's like having your own personal air traffic control tower. It's amazing.
And guess what? It's the exact same idea for ships out on the water. They use a system called AIS to broadcast their position and their course. So if you live anywhere near the coast or a big river, you can suddenly see all the marine traffic moving around you, from huge cargo ships to little sailboats.
Okay, this one is one of my absolute favorites. You can actually pull down images directly from NOAA weather satellites as they fly over you. You just point a pretty simple antenna at the sky, record this really strange series of beeps and squeals, and then a piece of software will turn that sound into an actual image of the Earth from space. I mean, come on, how cool is that?
And honestly, that is just barely scratching the surface. You can tune into shortwave radio shows from the other side of the planet. You can listen to ham radio operators talking to each other from different continents. You can even decode the data from your neighbor's wireless weather station. Or you could go hunting for those bizarre coded transmissions they call number stations. The list just goes on and on.
So, are you feeling inspired? Are you ready to dive in and start exploring this world? Awesome. Let's get you set up with a few pro tips so you can get started on the right foot and avoid some of the common mistakes.
All right, first things first, your antenna is everything. Match it to what you're listening for and try to get it outside and up as high as you can. 2, hunt down the noise. Your computer, your phone charger, all that stuff creates radio interference, so move your antenna away from it. 3, and this is important, keep transmitting radios away from your SDR. A powerful signal can fry its sensitive little circuits. 4, you gotta adjust the gain. If you leave it at 0, you literally won't hear a thing. And finally, number 5, pay attention to antenna orientation. Most signals are vertically polarized, so your antenna should probably be standing up straight too.
And it's really worth taking a second to appreciate just how amazing this is. Just a few years ago, having the ability to see this much of the radio spectrum would have cost you tens of thousands of dollars. It was stuff for governments and huge corporations only. And today, you can get all of that power for the price of a pizza. It is an unbelievably powerful tool for learning and just for being curious.
So there you have it. There's this entire invisible world out there buzzing with communication all day, every day. These signals are flying all around you right now, carrying stories and data and secrets. The only question left is, are you ready to tune in and start listening?